This is number 108 in chapter 16. It is a precipitation question, a fractional precipitation question, and it asks us to consider a solution, and the solution has two ions in it. One is our ferrous ion, or Fe plus 2, and it's 0.022 molar in it. And then we have magnesium plus 2 as well, but that solution is 0.014. And so we're going to use potassium carbonate to cause a precipitation. And so we can use it to selectively precipitate one of these cations and leave the other cation in solution. The first question is which will precipitate first? The iron or the magnesium? So we have to look at how potassium carbonate is going to affect these two guys. Right, when potassium carbonate goes into water, you're going to get two potassium ions and then a carbonate anion. And it's the carbonate that's going to cause the precipitation. We're not going to see potassium reacting with these metals because they're all positive. You're going to have the carbonate reacting. So if that's the case, these are the two reactions we're looking at. We're looking at iron carbonate and how it dissolves into our ferrous ion and carbonate anion. And then we're also looking at magnesium carbonate. Going into solution as well. So those are the two processes, and so we have to look up the KSP for these guys. Our KSP is going to be equal to our iron times our carbonate, and we have something similar for our magnesium. So the question is which one of the carbonate concentrations is less? The one that is the less of the two concentrations is then the one that's going to cause your iron to precipitate or your magnesium to precipitate first. So we have to go to a table and look up the KSP values. For our iron, the KSP is 3.07 times 10 to the negative 11th. And so that's going to be equal to my iron concentration, which is 0.022, times this carbonate concentration. And that's what we are looking for. We rearrange that, we can solve for our carbonate, and that is equal to 1.359 times 10 to the negative 9th molar. So that's our carbonate concentration required to cause the iron to precipitate as ferrous carbonate. So if we go above that concentration, we have precipitation occurring. Do the same thing for our magnesium. KSP for the magnesium is 6.82 times 10 to the negative 6th. That's going to be equal to that magnesium concentration, and then again we are trying to determine that minimum carbonate concentration. When we rearrange that and solve, we get a minimum of 4.871 times 10 to the negative 4th molar. So you see it takes a lot more carbonate to cause the magnesium ion to precipitate than it does the iron. So the iron is going to precipitate first. So iron precipitates first. And so that's the answer to the first question of 108. The second question is asking what is the minimum concentration of carbonate, or rather potassium carbonate, to trigger that precipitation. And that's what we already actually did. Right? We figured out for iron that carbonate concentration was 1.359 times 10 to the negative 9th molar. And then we figured out for the carbonate concentration for our, I don't know why I'm putting -3 there. There we go, -2. Was equal to 4.871 times 10 to the negative 4th molar. So again, that's why iron is going to precipitate first, and again, that's also then the minimum concentration of our potassium carbonate solution. Part B of this question is asking about the fractional precipitation part, and kind of asking, what is the remaining concentration of the cation that precipitates first when the other cation begins to precipitate. So the one that precipitates first is our iron, and so just to draw its equilibrium again, right, this is what's going to precipitate first, right? But the question is really asking, once the carbonate concentration reaches the higher mark, because at this concentration, that's when the other ion begins to precipitate. How much of that iron that's been precipitating, how much of that iron is actually still left in solution? And so we want to use our same KSP expression as we did in part A, but now we're not going to be solving for the carbonate, we're going to be solving for the iron. We're still going to use that KSP for the ferrous carbonate, and so that's going to be equal to, again, this iron 2+ concentration that's still in solution when the other ion begins to precipitate, and that concentration of carbonate is 4.871 times 10 to the negative 4th. And so then we can solve for that concentration that's remaining, and we should get a value of 6.302 times 10 to the negative 8th molar. So you began with 0.022 molar, and then caused precipitation to occur, and then when the other ion begins to precipitate, this is how much you have left of that iron. Notice a dramatic difference here as far as 2.2 times 10 to the negative 2nd versus 6.3 times 10 to the negative 8th. So a lot of that iron precipitated. That is number 108 in chapter 16.